Hello everyone, I'm Professor Sourish Dasgupta from DICT, and this is a joint work with my students Divya, Pathik, Ankush and Professor Tanmoy Chakraborty from IIT Delhi, who is my collaborator. The title of the work is Are Large Language Models in Context Personalized Summarizes Get an iCOPERNICUS Test Done. So the outline would be why personalization in summarization, and then what exactly is in context personalization learning, and then contrasting iCopernicus framework with some existing work on evaluation of personalization, and then finally some results. So what is personalization? Every user would have their own understanding of what exactly is salient information depending upon their varying user interest and how that interest evolves over time, and that's why we need personalized models. What is ICPL? ICPL is a special case of ICL, or in context learning, where you provide a document to the LLM together with some user profile information, which can be either the reading history, that is the temporal sequence of users' click and skip history of the documents, or the expected summaries of the users. And the job of the LLM is to utilize that information and then provide user specific optimal summary. This is how the prompt structure looks like, where you have the system instruction, where you make it very clear what exactly is personalized summarization, and then you put in the user click history, and then you can put in the input examples, and then you provide the query document as the task. So before we move on to iCopernicus, let's have a quick peek at what EGISES does, which was published last year from our lab in EMNLP 2023 Singapore. So EGISES measures the extent to which a model discerns the differences between user profiles and thereby generates summary having proportionate differences, which means it just looks at the normalized ratio between these two distances. And just to make it a quick point, accuracy measures doesn't really do the job, because you can have very high accuracy while the personalization can be varied from very low to very high at the same time. So, so now the iCopernicus framework stands for In Context Personalization Learning Scrutiny of Summarization. The research question being, do LLMs harness three types of profile information included within test prompts, which means if we help the LLMs with richer user profile information, can they, in the form of examples of expected summaries or reading history or contrasting information, can they utilize that and perform better in terms of personalization? So there are three types of non-contrastive prompt structure. In zero shot, you just provide the click history of the user. In K shot, without history, you don't put the history, but you provide the examples or the goal references or expected summaries. And in two shot with or K shot with history, you combine them together. The contrastive version of these would be where in zero shot you provide multiple user histories as a contrast to each other, so that make it very explicit to the LLM how they differ. The same thing goes for without history, but where you just do that, the same thing for the expected summaries, but not in the history. And then you combine them both. That's the third case. So what we are trying to understand is, in terms of, let's say, the example summaries, are the LLMs able to utilize this additional information, and or are they showing some sort of paradox, which we call as paradox one? So in other words, if we provide keyshot prompt in different settings, which means the without history, with history, and in the contrastive setting, are they able to perform better in as opposed to the corresponding plain zero shot version? And we also try to understand whether the same sort of thing is happening for reading histories, which means if we provide history information in different settings, are they able to harness that or not? When we finally looked into explicit contrastive information, are they able to harness in different settings or not? And why not just simply EGISES? Because all these sort of personalized evaluation measures would evaluate LLM's ability to respond to differences only in terms of the user's profile, and they would not be able to understand how LLMs improve when aided with this additional information. So just to make sure that we understand, iCopernicus is actually not a metric but a test suite framework, and thereby utilizes EGISES as the comparative metric. So we generate the prompt dataset from the PENS dataset, which was released by Microsoft Research in 2022. And this dataset consists of a test set that included 3,840 news articles, and which were annotated by users in two different stages. In the first stage, the users were told to browse through 1,000 news headlines and click on 50 pieces he is interested in, and then later on come over to 200 different articles and then write their expected summaries. And we made sure that they made sure that each news has at least four annotations. So this is the statistics of the prompt dataset that was sampled from this dataset, and the overall prompt size remained fixed for fair comparison. These were the benchmark models. The baseline model remained Llama 2 and Mistral, while we looked into three different paradigms of fine tuning, instruction tuning, RLHF tuning, base tuning, and DPO tuning. And we found that except for two models, which is Zephyr 7B beta and Orca 2 7B, almost all the models rather, showed paradoxes. And the most interesting part is that if we look at how it performed with respect to only EGISES as the leaderboard, then we see that the best performing models are actually showing all the paradoxes, which makes it very clear that standalone personalized summarization, or rather standalone personalization measures are not going to work when it comes to understanding ICPL capability. We also look into whether the iCopernicus, sort of like a validation, we try to understand whether the iCopernicus results can be conclusive. So what we did was in the contrastive case, we replaced one of the contrasts with a random sample, thereby introducing a noise that is completely irrelevant to the document, and try to understand whether it's performing even worse, or rather, if it is distorting even worse, as known results suggest that it would. And we saw that yes, that is actually happening, which means the iCopernicus tests were not really equivalent to the random test. Also, another thing we did was we replaced EGISES with a server-based human judgment version of EGISES, and we tried to understand whether three models, the best model, the medium performing model, and the worst model, whether their contrastive cases are paradoxes are still being retained or not. If we just replace the EGISES with EGISES 8J, which is the human version of the EGISES measure, and we saw that yes, the paradoxes still exist, which can help us to understand that yes, iCopernicus is not just a coincidental set of results, and human judgment also agrees with that. These are the references that were used in the paper, and thanks a lot. for giving us the opportunity. See you at Miami.